Hey y'all, welcome to lecture number 21, going over chapter 6.3, matrix operations. We are going to get started with defining the order of a matrix. So the order of a matrix is determined by the number of rows and the number of columns. A matrix with m rows and n columns is an m by n matrix, read as m by n matrix. So what we're going to do is determine the order of each matrix first. So you can see here on our first matrix, we have one row, two rows. We have one column, two column, three columns. So this is going to be a 2 by 3 matrix. For our second example, we have one row, two row, three row, four rows. However, we have only one column. So this would be a 4 by 1 matrix. And our third example, we have one row, but we have 1, 2, 3 columns. So this would be a 1 by 3 matrix. All right, not too bad, right? Number of rows by number of columns is how we classify our matrices. Okay, so next we want to use the matrix notation. So essentially the A with the subscript denotes the spot in the matrix. All right, so we've got row 1, row 2, and row 3. Across the top, we'll have column 1, column 2, column 3, and column 4. So A32 means row 3, column 2. So we're looking here on row 3. This is row 3. And then we're looking in column number 2. So that gives us this here, 8. So A32 is going to be entry 8. Okay, next, A23 means row 2, column 3. So looking in row 2, and then looking in the third column, we find 0. So the entry in row 2, column 3 is 0. Next, A14 means row 1, column 4. So we're looking across our first row, and then we're looking in our fourth column. That gives us negative pi. So A first row, fourth column equals negative pi. All right, so essentially all this definition is saying A equals A sub I sub j. The I is the row number and the j is the column number. Not too bad, right? Let's keep moving on. So next is going to be equality of matrices, and two matrices are equal if and only if they have the same order and if their corresponding elements are equal. So for these to be completely equal, it means every single one of their corresponding elements has to be equal. So that means row 1, column 1 must equal row 1, column 1. And then row 1, column 2, so this is 1, 2, 1, 2, 1, 2, 1, 2, must equal row 1, column 2. So that means y equals negative 4. It must equal negative 4, or else our matrices will not be equal. Next, row 2, column 1 must equal row 2, column 1. So that means x equals 9. And finally, row 2, column 2 must equal row 2, column 2, which means that z equals 7. And that is it for matrix equality. They are only equal if each row 1, column 1 equals the other row 1, column 1. So if this was matrix A and this was matrix B. You see? Okay. Oh, and then it's saying also the same order. So we can see that matrix A is a 2 by 2 matrix and matrix B is a 2 by 2 matrix as well. So if you were to have had something like 3, negative 4, x, z as your A, and as your B, you would have had just like 3, 9. These could never be equal because matrix A would be a 2 by 2 matrix, while matrix B would only be a 2 by 1 matrix. So they have to have the same order as well as all of the same elements, okay? Not equal. Okay, next we want to learn how to add and subtract matrices. So to add and subtract matrices, we do have a couple of clauses. First is that the matrices must have the same order. So we can't add and subtract matrices of a different order. So let's go ahead and get started. So matrix A is going to be a 2 by 3 matrix, because this is 1, 2, and then 1, 2, 3. Matrix B is also a 2 by 3 matrix. And matrix C would be a 2 by 2 matrix. We call matrices that have the same number of rows and columns square matrices. So 2 by 2, 3 by 3, 4 by 4, those are all squares. So first we will do A plus B, and matrix addition is pretty nice. All you are going to do is add row 1 with column 1 is going to be 3 plus 8. And then our entry for row 1, column 2 will be -7 minus 3. Row 1, column 3 will be 0 plus 4. Row 2, column 1 will be 1 plus 0. Row 2, column 2 is going to be 4 plus 1. And then row 3, column 3 is going to be -6 minus 9. So that means matrix A plus B is going to be 11, -10, 4, 1, 5, -15. And that's it for adding and subtracting matrices. Next, we want to do B minus A. Again, it is the same strategy. So B minus A, we're actually this time going to start with the B matrix first. So that means we'll be taking 8 minus 3. And then we'll have -3 minus -7 is going to be -3 plus 7. 4 minus 0. Moving on to row 2, we'll have 0 minus 1, 1 minus 4, and then -9 minus a -6 is just -9 plus 6. So that is going to be 8 minus 3 is 5, -3 plus 7 is 4, 4 minus 0 is 4, 0 minus 1 is -1, 1 minus 4 is -3, and -9 plus 6 is also -3. So it is pretty straightforward. You just add and subtract the numbers in the corresponding row and column. Lastly, you want to do A plus C. However, our matrices must have the same order. And then since A is 2 by 3 and C is 2 by 2, we cannot add. And that's it. The answer is just that it cannot be done because they are a different order. Okay, let's move on. The additive inverse of a matrix is denoted, or if the matrix is A, it's denoted by -A. And essentially all of the elements are just negative of the original element. So what this is saying, -A equals -Aij, is just saying you take the negative of each of the entries of the matrix. So -A would equal, so we look at row 1, column 1. So A of 1, 1 is equal to -4. That means -A of 1, 1 is going to be 4. And that's what this notation right here is saying. You just take the negative of each entry. So now we want to look at row 1, column 2. So we're going to get -5. Row 1, column 3 is -1, so we want a positive 1. 0 is just 0. And then row 2, column 2 is -3, so we'll get 3. And row 2, column 3 is 2, so we'll get -2. What is significant about the additive inverse? Well, let's find out. So let's do a plus its additive inverse, which is -a. So that means we'll have -4 plus 4, 5 minus 5, -1 plus 1. Can you guess what's going to happen? 0 plus 0, -3 plus 3, and -2 plus 2. So we get the 0 matrix. And that is why it's called an additive inverse, is because when added to the original matrix, you get the 0 matrix. All right? Let's keep going. So the next thing we want to talk about is going to be scalar multiplication. So a scalar is essentially a number, but you're multiplying the number by the entire matrix. So the definition is we look at the product of a real number k and a matrix. This is called scalar multiplication. The real number k is called a scalar to distinguish it from the matrix. So here 2, this is a scalar, and 4 is a scalar as well. So the first thing we want to do is find, well, we want 2a for sure. So 2a is just going to be 2 times every single entry in our matrix A. So that's going to be 6, -10, 0, 2, -8, 4, right? If I'm multiplying everything by 2. And then next we want to find a plus b. So a plus b, because a plus b is here in this parentheses. So a plus b is going to be, I'll have 3 minus 8, which is -5, and then -5 plus 9, which is going to be 4. And then I'll have 0 plus 4, which is 4. I'll have 1 minus 1, which is 0. -4 plus 0 is -4. And then 2 plus 3 is 5. All right. Next, we need 4a plus b. So we want to do 4 times a plus b, which is going to equal 4 times our a plus b matrix. So we'll get -20, 16, 16, 0, -16, and 20. Lastly, we want 2a plus 4a plus b. So that means we're adding this matrix plus this matrix here. So the first thing that I'm going to do, the first thing that I will do is row 1, column 1. So 6 minus 20 is going to be -14. Then we have -10 plus 16, which is 6. 0 plus 16 is 16. 2 plus 0 is 0. -8 plus -16 is going to be -24. And then 4 plus 20 is 24. So here's our final answer, and I hope y'all didn't think that was too bad. Okay, let's move on. All right, next we want to solve a matrix equation. So we are actually looking for x. However, it should be noted that x in this case is a matrix. So note that x is a matrix. Okay, so what we want to do first is we can kind of solve this like a linear problem where we want to get x by itself first, right? So that means if I'm looking here at 4x minus a equals b, that means that 4x is going to equal a plus b, which means that x is going to equal 1/4 a plus b. So that means the first thing that we're going to want to find is a plus b. So A is a 2 by 2 matrix, B is a 2 by 2 matrix. That means we are allowed to add them since they are the same order. So A plus B is going to be, so we'll have 2 plus 6, which is 8, 5 minus 1, which is 4, 1 minus 3, which is -2, and then -4 minus 8, which is -12. And then to find x, we need to take a fourth. Our scalar here is 1/4, if you want to remember that from the last slide. So we're multiplying by the scalar, so 1/4 a plus b is going to be, so 8 times a fourth is 2, 4 times a fourth is 1, -2 times a fourth is -1/2, and -12 times a fourth is -3. So that means this is our X matrix. All right, let's move on. So next we're going to go over how to multiply matrices. This is kind of a complicated process, but we can do it together. So the first thing is that there is always a rule. So this matrix is a 2 by 3, and we're multiplying it by a 3 by 2 matrix. Whenever you're doing matrix multiplication, what's really interesting is your resulting matrix is going to be the outer two numbers. So here and here. So that means our resulting matrix will be a 2 by 2 matrix. And it will always be like that. So like if you're multiplying a 3 by 4 matrix with a 4 by 2 matrix, your result would be a 3 by 2 matrix. So the middle numbers have to match in order for you to be able to multiply. That is the rule. So remember, these two middle numbers here always must match, like how we had 3 and 3. Okay, that's very important. So our middle numbers match. We know we're going to expect a 2 by 2 matrix. So now the question is, how are we going to get it? Our 2 by 2 matrix is going to be row 1, column 1, and then we'll have row 1, column 2, row 2, column 1, row 2, column 2. And you may think, oh, well, that's kind of obvious. However, the process is slightly tricky. So when we're looking for, I'm just going to put equals here, and I'm going to do scratch work down here. So when we're looking for row 1, column 1, what we're going to do is we're going to take our row 1 from A and our column 1 from B, and we're going to match elements. So row 1, column 1 is going to equal, so our 2 is going to go with -1. So we have 2 times -1 plus the second term, so -3 and 10, so -3 times 10, plus the last entry, which is 1 and 8, so we have 1 times 8. So this is equal to -2 minus 30 plus 8, which is -24. So row 1, column 1 is -24. All right, next, we want to do row 1, column 2. So again, we have row 1, but now we have column 2, and we start to match our elements. So that means we'll have 2 multiplied by -6 plus -3 multiplied by 5 plus 1 multiplied by -2. This is going to be equal to -12 minus 15 minus 2, which is negative 29. So my row 1, column 2 entry is negative 29. Next, we will do row 2, column 1. So I have row 2, column 1. It would also be important for me to specify that when we're looking for AB, our rows are coming from A and our columns are coming from B. All right. So we'll have negative 4 times negative 1 plus 7 times 10 plus 0 times 8, which is going to be 4 plus 70 plus 0, which is 74. And then lastly, we'll have row 2, column 2. So my rows are coming from my A matrix because we are finding AB. My columns are coming from my B matrix. So that's going to be negative 4 times negative 6 plus 7 times 5 plus 0 times negative 2, which is 6 times 4, 24, plus 35 plus 0. So that's going to be 59. So this is AB. Note that instead, if we were looking for, so this is just a side note over here, but if we were looking for B times A instead, then we would have taken our rows from B and our columns from A. So it depends on the order that you're multiplying, because BA is going to give us something different than AB if you think about it, because BA would be a 3 by 2 multiplied by a 2 by 3. So BA would actually be a 3 by 3 matrix and not a 2 by 2. So you're going to get something completely different if you did BA instead of AB. All right, let's keep going. Okay, so next we want to find AB, given A is 2, 5, 1, 0, and B is 1, 0, 6. So A is a 2 by 2 matrix multiplied by B, which is a 3 by 1 matrix. Our middle numbers do not match, so we cannot multiply. That one wasn't too bad, right? Middle numbers don't match, can't do anything. We just move on with our lives. So let's now do number 2, find BA. So A is a 2 by 2 matrix, B is a 2 by 2 matrix. So that means BA is going to be 2 by 2 times 2 by 2. 2's do match, so that means overall we're going to get a 2 by 2 matrix. But here's where we're going to have to be careful, because now it's looking for BA. So that means we are going to get our rows from B, right? And our columns from A. All right, so remember, for a 2 by 2 matrix, that means BA is going to equal row 1, column 1, row 2, column 1, row 1, column 2, row 2, column 2. So first we'll do row 1, column 1. Row 1, column 1 is going to be, here's our rows now, because we're taking B times A, and columns. So that means I'm going to have my 1 times my 3 plus 0 times 1, which is just 3, right? Because 3 plus 0. So that means, here, I'll write over here. So BA is going to be, so we have 3 as our first entry. Next, we want row 1, column 2. So again, my row 1 in the B matrix, and then my column 2 in the A matrix is here. So I'll have 1 times -4 plus 0 times 5. That's very nice that this 0 just keeps knocking stuff out for us. We just get -4. And then next I want row 2, column 1, which is going to be row from my B matrix, column from my A matrix. So I'll have -3 times 3 plus 6 times 1. So it's going to be 9 plus 6, which is 15. And lastly, I want to find my row 2, column 2. So that's going to be row 2, column 2. So I'm going to get -3 times -4 plus 6 times 5, which is 12 plus 30, so 42. So here is the BA matrix. The last thing that I want to mention is that when you have stuff like this, that's just one single column, we actually refer to it as a column matrix. Similarly, a row matrix would be if you had something like this. Oops, sorry, bracket. This would be a row matrix. So just so you've heard that term before. Column matrix is one column, a row matrix is one row. This is going to be it for this lecture. Thank y'all so much for tuning in, and I hope you'll have a wonderful rest of the day.